You ready?
Yep.
All right, so I'm starting now.
Yeah.
Go.
Okay. Well, good afternoon, everybody. I'm Dario Castañé. I work at Datadog as open source library maintainer for DDTrace Go, our Go SDK for APM, ASM, profiling, and other products. So, quick show of hands. Who is using Datadog right now for instrumenting their code? Oh, well, okay, that's fair. So this is for you. In the next minutes, we'll go from a basic Chi server without any DDTrace Go to that exact source code, but sending traces and information to Datadog. So how are we going to do that? We are going to use Orchestrion. Sorry, forgot to put back the slides. So Orchestrion is a tool that transparently adds instrumentation to your Go applications for mainly application performance monitoring, application security management, and profiling. It works thanks to a Go build flag called toolexec. That's the key for this to work. It allows to control, modify how the Go toolchain programs get to run. With no further ado, I don't have a lot of time, let's dive into the code we are going to instrument. As you can see here, we have a very basic HTTP server using the Chi framework. Also, I have a function that generates requests. Nothing fancy, right? It has some login, the usual stuff. OK. So let's set up Orchestrion right now. It's not good to work with two displays. Now I realize that. OK, so let's do this. I'm going to run make setup. I just prepared that. This is running a command called Orchestrion pin. This is setting up Orchestrion for you. And if I show you the Go mode, you will see that it already included everything. I can do it again, but so you can see the differences. OK. OK, yeah. Let me just do. It just failed, demo effect. It should have removed everything, just leaving the Go Chi line. Anyway, we did that. So what's next? We are going to show you the different. I'm going to show you that in the data that we are right now, there is no data. OK, thank you. There are no traces. There is no profiling right now. And there are no logs. OK. Not a great demo right now, but let's just run this command. Now I'm running Orchestrion Go build. That means that I'm running Go build, injecting Orchestrion, and it generated a binary that is run it, and it's already instrumented. So right now, this is sending traces. As you can see here, logs, without any modification, just running through the tool Orchestrion, the logs are already being sent. Don't fail on me. Nah. I got scared for a second. Traces are in, and profiling should be working. Oh, it takes a little bit longer to refresh profiling data, so. Oh, good eye. Thank you. Yeah, it takes longer to refresh the profiling, but the main thing is that with that, OK, I see a game over, so only the last, the last one. Yeah, what we did is we get the code, we run it through Orchestrion, and boom, we got the instrumented code. If you want to know more, these are the links and videos and everything that you need to know. And please ask me any question that you have. There is the QR for the slides too. Thank you.
Thank you. All right, next.
very well. OK.
Ready, set, go.
Hi, I'm Jorropo. I'm a contributor to the Go compiler. And today I'll tell you why do we not have tail call optimization in Go, because that's a question a few people have asked me. So I will start the story by telling of a tool I was building, Turn the Dupe. It's a tool that scans your file system. It finds duplicate files by comparing hashes. And when you find duplicate hash, it does a ref link, which is a feature on a fancy file system like BTRFS. And that allows you to have the same content in multiple files, but while using the disk space of one only. And it's copy and write. And so I profiled, and I found that os.file.read is slightly expensive, like 95% or so. The problem is if you use pprof to profile, which I was doing at the start, you can see that it tells you that, oh, you are doing syscall, which means you're in the kernel, but it doesn't tell you what's happening inside the kernel. So we can bring the big guns, which is perf. It's a Linux tool to profile code. And it gives us this result. It tells us that we have VFS read, which is taking 95% of the time. And VFS is the system in Linux that, hey, that's like, for this path, which implementation I need? Do I need BTRFS, ext4? And we see the implementation it's been called is file map read, which is the page cache, which is slightly interesting. And so I'm like, OK, so can I disable the page cache? And so the goal of the page cache is to take your files and store them in unused memory right after you read them. So if you read them quickly again, then you don't have to go back to the disk. But I have fast SSD. I shouldn't need this. And so I look at VFS read, and I look at where it's calling file map read. And as you can see, well, it's not really calling file map read. If we look at the function with the arrow right here, it tells us that this is the hot function. But like, it's not file map read. And so I'm confused at this point. I waste 30 minutes on this, and I remember that, oh, this is not Go. I've left Golang. This is C now, because this is the Linux source code. And so I have to add this magic flag. The slides don't really like the zoom. And so now I add the two magic flag. I recompile the kernel. I wait for an hour. And I found this function, BTRFS file read iter, which is actually the one that I want. And I can see that it's calling file map.read if I don't have the IOCB flag direct set. So I do like Google Linux file direct. And I found this option called odirect. And it just lets you bypass the page cache. And when I tried it on my machine, it went from 2 GB a second to 6 GB a second. But now the real question is, why did I have to add like this two things just to get the proper result? And so that's what tail call optimization do. So the base idea is like, we have two functions, and we have G calling F right before doing a return. And that's how it would pseudo-compile. So it's kind of what it would look like. The key thing to notice here is we don't have a call really in assembly. We only have goto. But what we can do is we can grab a pointer to the code, and we can pass it to the other function. And we can also goto to the value of a variable. So we can see that f goto to the region pointer, and the region pointer was set to a label that's right after. And that's how it works in Go. But if you do TCO, then what happens is that we can just not do that. What that means is that the region pointer that was given to you, you're giving that to the function you're calling, and then you just goto into it. And so that has the side effect of, if we look at the stack, we start with VFS read, right? And VFS read called BTRFS file read iter, and that's how the stack looks. And then BTRFS file read iter called file map read, and file map read then has the new stack, and there's just BTRFS file read iter is not in the stack at all. And so now when perf goes to look at the backtrace, it follows the base pointer, and it look at the return pointer using the base pointer, and it look at all the function. It's like, well, I mean, VFS read calling file map read. So that's kind of the thing. It's the feature of being able to backtrace is part of the STD in the runtime package with callers. And so if we did TCO, that would break this. And there might be workaround in special condition, but then it's really complex to implement in the compiler. And the other argument I was given is that it's not actually making your code that much faster. Doing the extra call is not expensive. Modern CPU is very fast at doing call because turned out people use functions a lot. And so it's more about being able to write this kind of code, which is functional style. And if we would have one compiler that starts being able to turn the first, my loop example into a loop, which like TCO does, it removes the need for recursion, then all the Go compiler might need to implement this. Otherwise, we will have a Go code that works on one but not on the other.
5. Perfectly timed. Truly incredible. Okay. Excellent. Ready?
Okay, I think.
Set. Go.
Hi, I'm Tanguy. If you want to know about me, just talk to me. I only have 5 minutes, and since I'm a little bit stupid and I don't learn my lessons, I will live code. So I'm going to talk about REPT, which is rest in peace on steroids. Rest in peace. It's a library that generates RESTful HTTP handlers for a resource entity. So you can check that out on a QR code. So as Robert said before, live coding, don't do it. Anyway, I'll do it. So I have 5 minutes to create a full CRUD for, let's call it an album library. So let's go with main. I'm gonna first, I'm going to declare my type, which will be album. For that, I need like a name. I need also an artist name. And of course, I need an idea to be able to identify it. So I want to save that on a DB. Because I'm lazy, I'm going to use GORM that will open some SQLite database. And since I like to live on the edge, I'm going to just save in memory. Going to do some error handling just for the sake of it. I'm going to automatically migrate my database with my type that I just created. So it's going to generate all the table that I need for. Then, once I have that, I'm going to start using rest in peace, and I'm going to use a provider, which basically is use the database driver to generate the create, read, update, and all that CRUD stuff. For that, I'm going to call it album provider, and I'm going to get it from my GORM provider and do a new, given the album type, I'm going to pass the DB and the slug default logger. Then I'm going to create my route options for my router. And so this is rib.new route options. Don't even use the LSP, sorry, Alan. And I'm gonna embed codecs. So for now, I'm gonna just do HTML new. Oops, does it imply that that's just? Sorry, I'm gonna get some help from the LSP still. So with my codecs, I'm gonna get the HTML codec. It doesn't get it. Okay, new entity codec. Anyway, album, and I'm gonna do the same for, this is read-only codec. This is to edit the codec. Now that I have my route options that are good, I can start using the net-HTTP handle func and pass in my handle entity. Can you help me now? No, I didn't. Handle entity. I'll pass still. This is repetitive, the album. I need to improve the API, but anyway. And I'm going to pass my album provider, my route option, and then I can start listen and serve. Yeah, thank you. Let's put it on 555. Let's use the default router. And it doesn't like, yes. Okay, why? Are you not happy? Damn it. the path. What is wrong with the path?
First argument to handle point.
Sorry? Handle? Handle entity? Yeah.
You need a string.
Yeah.
Handle font takes a string.
Yes, but it actually returned 2. That's why. Okay, is it that? Got it. I need my doc because I'm... no, okay, you need the... Doesn't want to help me today. How much do I have? Yeah, I know, it's coming. Oh yeah, okay, go more tidy. Why? Right, I just did it, okay? Okay, 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 now it's running. Go run dots. Let's try and, okay, and full string, yes. Okay, so,
I'm giving you 30 seconds extra, of
okay,
which you
so
have
now
another
I have
6,
my thing.
5,
I can
4,
iron
3,
and
2.
Ciferum. Okay, that's EN, the new artist. And now I have my album list that is available, and I can modify it. Like, let's put the real title. Boom, which is a great album, by the way. And that's it.
Thank you.